Okay, here we're asked to write a piecewise defined function definition for this curve here. So I'm going to do it here in blue. Okay, now what I'm going to assume is that, and I think we have to go through with these and assume that they continue on in those directions. If we don't, it's not a problem. We just have to limit our intervals for our domain for each particular part of the piecewise defined function. Now, I need to go ahead and come up with the curve for here on this inside piece, which looks like it goes from -2 back to -infinity. So we'll call this entire curve f of x. And now I want to look for when x is strictly less than 2. So it looks like it's got the squared function. If you go over 1, it's at a height of 1. If you go over 2, that guy would be at a height of 4. Okay, so this is pretty clear that this guy right here is the squared function, and it is defined everywhere to the left of 2. Now to the right of 2, it looks like my function is obviously linear, and so we need to find the slope. So as we move 1 over, it looks like we go 1 up. So it looks like the slope of this guy is 1. So the m value is 1. It also looks like the intercept value, and there's two ways to do it. We can grab 2 points in here, or we can just count back to do the intercept value since the slope is really nice. So that'll take us back 1, over 1, back 1, over 1, which puts us at -1. So it looks like x minus 1, I can actually write that lower, give myself a little bit more space. X minus 1 is the function that's defined when x is strictly greater than 2. Now you might ask, what about when x is equal to 2? Well, in that case, the function is undefined. And so when x is strictly 2, this function doesn't have a value because these are both open circles. Now that's not a problem. It still is a function. It still passes the vertical line test. However, it's just that 2 is not in its domain.